I'd like to introduce everybody to Peter Shaw and his co-conspirator Rob Sullivan. They're going to be presenting today Postgres SQL tour de force. And I just want to mention that Peter is one of our managers, and he's also a new, again, author, and just an all-around great developer for helping with Lidnug and everything he does in the world. I don't know Rob so well, but I'm assuming that we'll learn about Rob during the presentation. Take it away, Peter.
All right. Well, hello, guys, and welcome to another Lidnug presentation. This is slightly different format to what you're usually used to seeing. Today, as Dan mentioned, myself and Rob Sullivan, sorry, I nearly called you wrong there, Rob. Say hello.
Don Sullivan?
Yes, Don Sullivan or Rob Sullivan, whichever you prefer. Rob is a self-styled data magistrate, and together we're going to fill your head full of info about the world's most famous open source database, PostgreSQL. So at this point, I'll let Rob come in and say a few words as well.
Cool. Well, I thought we'd just kind of start setting the groundwork with some basic slides. As Peter mentioned, we're talking about Postgres today. What is Postgres? It's the world's most advanced open source relational database. That's a bit of a mouthful to take in, so I thought it might help to break that down a bit. So what is the world? Well, it'd be Windows, Linux, OS X, BSD, Solaris, something called True64. I have no idea what it is, but it kind of shows the all-encompassing nature of Postgres. It basically runs on anything. And what does advanced mean? You can do complex queries. You can do optimistic concurrency, transactions, B-tree indexes, inverted indexes, R-tree indexes, all sorts of different types of indexes. You also get things like replication, hot, warm, streaming, synchronous, asynchronous, all really cool stuff that you don't get in basic projects. They're all part and built into the full flavor of Postgres. It also has an extensions network, which is really neat. We'll be looking at that a little more in the demos. And of course, the object relational, which is probably what we're all most familiar with. Tables, joins, constraints, dates. But that's not just relational stuff. It has things like arrays, core data types that we use in programming, and also really unique aspects like range types, where you can put in different values, and it understands the range, the max and min of these values without having to add your own logic layers. And of course, it's a database. At its core, it just stores things that we can feed up to the developers and their applications to fill in their pretty tags. And I think one of the things that really interested me about doing this was being able to team up with Peter and have an app dev side and a DBA side, as opposed to not just getting the story from one source.
Yep, absolutely, Rob. So what I'm actually going to do later on in the presentation is I'm going to show you all how to wire up the entity framework stuff to work with Postgres rather than just SQL Server. I've got a live desktop demo. I'm going to put together a small WinForms app, and I'm going to show you just how easy, or maybe not so easy, it actually is. Because, like everything .NET, there's a fair share of pain there, but we'll cover that shortly. And also, I think myself and Rob are going to do a little bit of a comparison between MS SQL and Postgres and show you just why you really need to seriously think about using Postgres and not just jumping straight for the MS SQL hammer.
Cool. Jumping back to the slides, a couple things I forgot to mention earlier is that it's not just a relational database. It has the capability of being a document store, which is really interesting if you're a developer. Not only that, the new version of Postgres coming out, 9.4, is going to be faster than MongoDB, which is really interesting. There's also the concept of GPU offloading, where if you're doing large-scale aggregates and things that do very precision floating point stuff that the GPU is optimized for. You can offload those units of work to your GPU using CUDA, which is just a really fascinating concept. And of course, you don't have to query tables. You can query Amazon S3, MySQL, Redis, MongoDB, Twitter. There's really some interesting possibilities that you can do. And of course, one thing Microsoft likes to mention about an enterprise edition of SQL Server is the column store. Right, so I'm familiar with that. There's now an extension for Postgres that lets you do column store queries.
So out in the wild, Postgres is used in a lot of places where many of you might not actually believe that you would even imagine Postgres being deployed to. Apple, for example, use it quite a lot. Microsoft use it a lot. Goldman Sachs, it's making some big inroads into the financial industry at the moment. Amazon use it for their products database and their warehouse systems. And there's quite a lot more as well. When I was researching for the book that I previously wrote for Syncfusion on Postgres, I was quite surprised to find that a lot of the American airlines use it for their booking systems, and a lot of UK companies and financial institutions use it as well. And I'm sure if we really, really dug into it, Rob and myself could find many, many more. What's the people who look after the airspace in the US called, Rob?
Would they be like the FAA?
The FAA, that's it, yeah. The FAA actually use Postgres for a lot of their systems as well.
Where I'm from in Oklahoma, there's a very large oil and gas industry, and they all lean on Postgres for the geospatial stuff. It's out in the world, probably one of the largest places you see the use of Postgres is its amazing geospatial engine.
Absolutely. I do a lot of GIS work myself, and some of the stunts that we pull with the complexity of some of the maps that we use just would not be possible without PostGIS and the Postgres extension mechanism that allows us to do things like that. In fact, what a lot of you may not realize, when you look at a Google Maps or a Bing Maps or anything like that, what you actually see output to the web browser is just bitmap tiles. But those bitmap tiles are actually composed in the back office, and all those roads and all the nice single colour stuff that you see on the map itself is all composed in the back end using Postgres by reading GIS data from shape files, by reading huge indexes with bitmap tiles covering every square inch of planet Earth, then composting them all together, then slinging them out to the front end servers for them to display in the mapping systems. And the speed this is done at is very, very scary indeed. I'm sure Rob will agree with that.
Yeah. It's pretty impressive. So you mentioned something about how Postgres and SQL Server might be similar.
Yes, well, I mean, one of the things that I like most in SQL Server are CTEs. Now, in my mind, a common table expression solves a huge amount of problems, and I try to use them wherever possible. Large, massive data imports, exports, being able to make temporary tables on the fly, using them in cross joins, joins within different groups, and then putting the groups together, then flattening a table structure. There's just so many possibilities. However, the one thing that I always felt should have been put into a CTE was the ability to make changes back to the parent tables that you're deriving your CTEs from. Now, Rob, we know that Postgres can do writable CTEs. Would I be right there?
That is correct. And I think, does SQL Server in 2014 do writable CTEs?
It does, but it's something that's only just been added to the product. It's not something that's been in there for the length of time that Postgres has had it.
Right. And that's some of the things. Like, this is a very transferable concept. You know, whatever platform you're on is, you know, the CTE and how much more readable and maintainable your code gets when you break things down into these units of work, and having the concept of writable CTEs where you can break down all this, so on a lot of reporting and large-scale aggregates, it's very beneficial for us to use the CTE to clear up and get a nice small unit of work, and then be able to take that and pump that into a new table or write it or update based on a rule set without having to reinvent the wheel all over again. I think Windows functions was another thing that was in Postgres first before.
Yeah, absolutely. The windowing functions like partitioning of table data and stuff like that. Because I mean, people need to realize one thing about Postgres, and that's the length of time it's actually been around. If I'm not mistaken, Postgres was actually in use way before any of the databases that we take for granted today. I think, yes?
I think if you go back, if you wind the clock back 2 decades, 20 years ago, you essentially have Sybase, which, you know, what SQL Server is based on. You had Postgres,
Yes.
which was like Berkeley DB at the time. Then you had the, I guess, the foundation of Oracle. I'd have to look that up. But again, it spans over 20 years. There's just a handful of these databases. That's why you see a lot of commonality, because the large database players now, they're all built off these cores that were set back a long time ago.
Mm-hmm. So, of course, Postgres SQL being what it is massively ANSI 96 SQL compatible then.
Yeah. Yep, it is. And I think another thing that's interesting or something worth pointing out is that the cost engine and query analyzer in SQL Server is, you know, one of its pride and joys. What was that?
Yeah, that was just
random. Right. And so a really cool thing about Postgres is that it's also had 20 years to refine and work on its query optimizer, which is really cool. And another thing you notice, like one of the big features about Windows Azure that's different than your standalone SQL Server is that Windows or SQL Azure, whatever, I don't know what the name is now of their product.
SQL Azure, I believe.
Thank you. That one is that out of the box, it uses optimistic concurrency. Right, so we're used to having locked tables with one transaction, right?
Mm-hmm, absolutely.
And Azure does optimistic concurrency. This is something that's been in Postgres for a long time now, and out of the box in all editions, you start with optimistic concurrency, so you're not fighting the deadlock game right out of the box.
And that's a pretty cool thing, because the amount of things and, well, I say things, the amount of applications whose performance I've seen is absolutely dire because of the transactional state of the data that's been read to and written from, and it just drives the performance down because SQL Server is locking things here and locking things there, and just generally being a bull in a china shop with your data tables.
Yeah.
You know?
Yep.
And
So,
sorry, go on.
well, it's just kind of thinking, you know, as I'm looking over like all the marketing checkboxes and everything, it just kind of boils down to like what you're doing is very similar between these two engines. And the main difference, I think, kind of comes down to how you do it. That's the differentiator.
Mm-hmm. Definitely. So, how's it not like SQL Server? Yes, I was just going to say that.
If you're coming from the Windows world or anything non-Unix world, Postgres by default is case sensitive.
Yeah, this is the one thing that's going to cause massive amounts of pain for .NET developers.
Right. It took me quite a while to get used to, because I'm just so used to SQL Server world where everything's case insensitive and it doesn't matter. You know, it's very forgiving, and anything Unixy is not forgiving of case insensitivity. I think another one that really jumps out. So you get a headache there, but you also have a lot of luxury in that there's no licensing model you have to fight with anymore. There's no version matrix that you have to resort to. When you get Postgres, you get everything all at once, which is
absolutely. One of the things I remember watching was a video on YouTube when I was researching my book, and in that video, the guy basically made a very, very, very big deal about being able to take the source code and any other bits you like from the Postgres project and use it in any way you see fit in any other project without actually having to contribute anything back to the open source project. And he actually went on to say that there are many, many, many database systems out there, both open source, closed source but free, commercial, and even things that you wouldn't readily identify as a database that have at their heart Postgres as SQL parser.
Yeah, and some companies care about money, some don't. As a DBA, one thing I hated in the Microsoft and SQL Server world was some devs would use local DB, some would use ExpressDB, some would use Web SQL. We would deploy to Enterprise Edition SQL, and trying to bring the data back and get uniformity all over the environments was just a complete headache because some things wouldn't restore, some would, just because of syntax errors and the license violations. It was just an ongoing pain.
Absolutely. And other points where Postgres is not like SQL Server, well, it's ANSI 96 compliant. Let me give you a perfect example of that. As we all know, from SQL Server 2008 onwards, Microsoft introduced spatial functionality into it for GIS and mapping purposes. Unfortunately, they did it in a Microsoft way. That is, they created the entire system of GIS and spatial functionality in a CLR object. What does that mean? Well, it basically means that when you're using your data within your columns and you're calling your GIS functions on it, you actually have a back-to-front method of using things. So things like where you might want to do an ST distance on two pieces of geometry, you actually have to do column name : geometry dot ST distance open parenthesis column name 2 close parenthesis. And then if you need to change the IDs on it, or the spatial reference ID, you then have to further put a .srid call at the end of it. And you have to chain the functionality in a fluent manner. Now, all the calls are standard, all the calls follow the OpenGIS specification in terms of them being called ST distance and set SRID and things like that. But unlike the standard, they can't be called in a normal, straightforward SQL statement like they can in Postgres and pretty much any other database. So back to front is the way that SQL Server does it, and as I like to say to people who ask me, it's the most compatible, incompatible way I've ever seen of it being done. I'm sure Rob would agree with that one.
Yeah, that's awesome. I think like the last big difference that jumps out at me is I mentioned earlier, the case sensitivity in the Unix way. In SQL Server, when you buy it, one of the nicest things, or one of the niceties, is when you install it, everything's inside the engine. All your performance metrics you want to query, all your backup and restore, that's all inside the engine. But sometimes things are missing, and you end up having to go and buy another set of tools, like Redgate Suite or whatever. So then you have a mix of internal programs and external programs. And in the Unix world, in the SQL Server, or in the Postgres world, a lot of things are external processes, and it comes very bare bones out of the box. So, like, in SQL Server, you have various DMVs, for missing indexes or whatever. In Postgres, you'll typically want to add contrib libraries or something else to start making it aware to collect those stats and make them easy to queryable. That was one of the larger DBA adjustments I had to have, was not being so reliant on everything coming out of the box inside the engine.
Absolutely, and let's not forget the massive amount of plugins and extensions that are available for Postgres.
Unbelievable.
It's just the mind boggles. There is everything available from enterprise-grade OLAP cube management right through to the aforementioned PostGIS and GIS support and everything in between. Now, Rob's going to show you some of the different data types and things in his demo, but it's just worth mentioning while we're here that Postgres has built-in native types for IP addresses, dates and times, ranges has already been mentioned, JSON objects, XML objects, URLs, and of course if you have a particular type of data that you need to handle in a specialist way for your business rules or your enterprise, then it's ridiculously easy to write an extension, and in fact I wouldn't be surprised if there is an extension available for it already.
Yes, funny you mentioned that. And my memory's a little hazy on this because some of the UK and Euro stuff, it isn't on my immediate radar, but I was reading the other day, like the banking industries in EU or whatever, they're starting to write, as they adopt more Postgres, they're starting to write their industry-specific data types or how they manage the VAT and things.
Absolutely, yep.
So I thought that was really cool seeing industry start to take ownership of that stuff.
Yeah, so you can actually, some of them are open source and a lot of them are not, unfortunately, but that may come in time. But there are one or two of them that have small open source projects where you can go and you can download an extension that, say, puts 20% on VAT here in the UK.
Yeah.
I believe there is actually an extension out there that connects to the Bank of England API and monitors interest rates and things and adjusts itself automatically. So you never actually have to go and put any formulas or any mathematics into your database, and you never need to change them, because it can all be done so automatically for you.
Yeah, really cool. Well, I guess everyone might be ready to see.
Well, we've got a couple of questions here, Rob, so let's answer them. So Kev asks, what about GPU support? Now, I'm assuming that you mean the GPU support that Rob mentioned before, Kevin, so I'll let Rob tell you a little bit about that.
Right, that's based on the NVIDIA language of CUDA. So you see, when you break passwords, you don't run it through your CPU. You rent a whole, you rent a fleet of GPUs from AWS, and you crack passwords that way. And that's using CUDA. And this takes on some of that same mentality of things that are very good for the type of operations that a GPU is optimized for. Parallel queries and sorting and things like that. When you enable this extension, and of course, you have a GPU that's compatible, this isn't just automatic fire and forget things. There's a certain amount of configuration and compatibility in your hardware. You'll start offloading those as it sees fit to the GPU. I hope that answers your question.
Yep. So, just while we're on the subject, what kind of things can we do on the GPU, though? Is it only mathematical operations, or can we actually use it to offload I/O operations as well?
So, yeah, the I/O is what's being offloaded. So you gather,
right, okay.
You query 4 million rows. Well, instead of passing that through your CPU for sorting, which it isn't necessarily good at, because it's just a general processor.
Yeah, absolutely.
You offload that to your GPU, which can insanely fast, and throwing, the 500 cores or whatever on your GPU, on modern GPUs, at it, and let the large-scale aggregate and sorting go through that, and then run it back through the North Bridge to the CPU and spit out the results. It's really cool.
Yeah. Makes a lot of sense. We did have another question there, but that seems to have vanished. Let me just see what it was. Right, so the other question was, for running queries in general, I found moving from SQL Server Management Studio to pgadmin 3 a bit frustrating. As an example, upon starting execution of a query, the pgadmin IDE seems to freeze up until the query execution is completed. I have found using SMSS to execute queries against PostgreSQL challenging. Issues with Boolean values in the 64-bit version of the driver required that I write queries to convert those fields. I'm interested in hearing what tool people use for that. Okay.
There's a lot of info in that question.
It is indeed. Well, I'm sure Rob has his own preferred tools. I myself personally use pgadmin 3 most of the time. The only other thing I tend to use when it comes to Postgres is a professional commercial product called Navicat Premium.
Correct.
But I use Navicat mainly because not only does it cover Postgres, but it covers many other databases as well. And I can use different databases all from the one interface. I've certainly never had pgadmin freeze up on me doing a query like that before, though. What about you, Rob?
I'm basically in the same boat as you. When I'm doing a lot of EBA stuff, I stick with just the plain command line in Postgres called bsql. Again, I'm not full-time on Windows anymore, so I'm on the OSs that really favor and really work well with command line utilities. So in my day-to-day, which maybe not applicable to you, I use a lot of the command line stuff, and I use a lot of pgadmin 3 for DBA work. When it comes to dev type work, I'm right there with Peter, and I use Navicat because just it interops so well with everything. You can get it. They run quite a few discounts.
In the past, I've used Toad as well, because I believe you can get Toad for Postgres. But Toad mainly tends to be an Oracle-orientated product, I think.
Yeah, but to the initial comment, I haven't found very good work from Microsoft on getting Management Studio to connect very well to Postgres, whether it be in SSIS or in just straight SSMS.
Well, to be honest with you, I've never actually known that you could connect SMSS to other databases. That's actually a new one on me, I have to say. So I think I'm going to go and have an explore and a little dig into that later on, see if I can find anything out.
My general philosophy, though, is that I use the tool built for the environment.
Yeah, absolutely, and that's really the way you've got to go. The other way of looking at it is use the tool that's comfortable for you. Going back to Rob's point on the environment there, if I'm sat at a Linux command line and it's faster for me to just type up PSQL than actually switch back to my Windows desktop and then hunt around for a GUI application to use, then I will use the command line. But the same applies for Visual Studio and any of my development tools as well. If I'm sat with PowerShell or command.com open and I need to hack together a quick C# program, then I'll just sit there and I'll use CSC at the command line rather than waiting for a whole Visual Studio instance to fire up. You know? So it swings and roundabouts, what works for you, what doesn't. Always think about what's best for your project and what makes your job easier and quicker, I reckon.
Yeah, it's also fun when you get the flip side of Postgres people who go to the SQL Server world and they have to use, when you've been used to incredibly lean tooling like pgadmin 3 and the psql command line utility, when you get just this massive Titanic IDE that is SSMS, how they react to that, it's pretty entertaining.
Yeah, absolutely. Right, anyway, so I believe you're going to actually wow everybody now, Rob.
Well, let's just start looking at code because that's way more fun.
Well, just to set the mood here, people, I had looked through Rob's slides before, and I like to think that I'm pretty good with Postgres. Some of the things that Rob's got in what he's about to show you took even me by surprise. So, take it away, my friend.
So here, this is a common select. We're just going to look at some of these really basic things to show that there's no weird magic that happens when you go to Postgres. It's still, select, create, update, drop, delete, where, all the things you're used to. And we start with just a simple select. When we get our version, we see that I'm running on Windows, 64-bit. This is the version of Postgres. Pretty straightforward. How do we create tables? Same way you're used to. How do we update them? Same way again. How do we delete? This is all pretty basic or pretty common for everyone. Pretty simple.
Yep.
Well, how do we perhaps get data into the table? So in SQL Server, you might use SSMS Studio and launch a GUI or any number of things. In Postgres, we can just use this simple copy command, specify the table name, and then where we want to import from, and just say how we want to limit it. And this file is right here if you want to see it. Actually, there's no magic happening, different types of burritos. Select it, 3 rows here, 3 rows there. Let's check them out. Boom. It's just very simple and very clean, very extensible. How do we export? Same way. Here I'm just piping out to my terminal. What's my delimiter? Let's just do a pipe and go for it. Pretty cool. How about indexing? How would we index? In SQL Server, it's almost taboo to index functions, correct? So it pretty much always takes you to a table scan. Not so in Postgres. Here, we're lowercasing the burrito name and indexing that so that now, when we go to query the table, oh, hold on.
In fact, if you even so much as suggest indexing functions to most MS SQL DBAs, they'd probably have you on a wanted list before you could walk away from the keyboard.
All right, how about I get an actual burrito name that we imported. It's fine. So we explain it. We can use a GUI explanation. GUI explanation. We get our glyphs that we're used to. Here we just see it's a simple sequential scan, which is the same as a table scan in SQL Server. Does anyone know why it's not using the index here? If we were in SQL Server for this type of example, would it use an index?
It probably would, I would guess. But it would. It depends. I mean, if you've got it set up for a full text, it might not.
It probably wouldn't use an index because since we only have 3 rows in this table, the optimizer is smart enough to say, I'm not going to even bother with indexes with a table this small. It's just way easier for me to load it up, from the table scan and filter down that way than using any index. Then that's a commonality between the engine's smart enough to know the best way to get to these things.
So the engine actually self-optimizes its optimizations then?
Yeah. In the same way in SQL Server, it would likely not use any index regardless, because it said, the table's so small, why are we even bothering?
Mm-hmm.
So you have the GUI, what you're used to. You can play the same hover over game like in Management Studio. So we know that we have to try and hover over the different glyphs to see them. But I get tired of glyphs. I like having a nice, simple text-based output that I can look at. So here we see a sequential scan. We see our cost, our before and after cost, and some other stats. But maybe this isn't friendly for everyone. Maybe you need more stats, and maybe you want to look at it in a different format like YAML format, where it's a little more human readable. So now we added analyze, which is going to give us a lot more stats, and the presentation is more in line. Does that make I don't know necessarily how to explain that, but instead of just having 0.00.1.04, we're seeing that now it's startup cost and total cost. Mm-hmm. It's adding a lot more context to it. And maybe we don't like YAML for some reason. Maybe we want the output in JSON. Right? Maybe we want to start logging this as JSON somewhere.
Or maybe we want to start going behind Postgres' back and taking the output from Postgres and putting it into MongoDB. Who knows?
Yeah. I just thought it's really cool seeing that Postgres so much wants to work with you and how you consume data in the ways that you want to see as execution plans. And it gives you a lot of different, and this is just 2 I'm showing, there's others. It's just really neat.
I'm assuming that XML comes just as easy as well as the others as well.
Actually, my keyboard is not very apt to allow me to type in XML. I don't know what the deal is there. So arrays, we mentioned arrays earlier. This is just an absolutely cool thing. So sometimes when we have to store many things, we might do column 1, column 2, column 3, or we might do a one-to-many table. But in Postgres, since it has this concept of arrays, we can just insert all of them in here. So here we're inserting Postgres, Redis, and Ruby. It's our tech stack, all in one go. And when we query it, we have...
And I can almost hear the, oh no, you're doing what cries out there?
So that you don't think that I just inserted a string, like a non-queryable string, we see the array-specific data type, and now the important part is that there's now value. Since we've declared it as a text data type, we can use different operators to say, show me all the rows that have Postgres in them, or show me all the rows that have Apple, and it knows, which would be none, it knows how to parse this and derive meaning from the data, which is really cool.
And one thing that's worth knowing as well, if you're programming PostgreSQL in .NET and you're using a library such as NPGSQL, you can actually take a list T, so a list of ints or a list of strings or even an IEnumerable, and you can save it directly using the ADO.NET calls directly into a column in your database like this. So you can take a list of integers and save them straight into a Postgres array column of int. You can take this list of text here, Postgres, Redis and Ruby, pull it back using ADO.NET, and you'll have a list of strings ready just to do some neat link query stuff on, using link to objects.
Yeah, we use it a lot at work for tagging. So, this could be, database, tech, code, any sort of like searchable tagging on it, and then index that, and then just use the array as all of our tagging. It's just one-stop shopping for all that kind of metadata surrounding some of our stuff. Here's a really cool one called inheritance, and this is near and dear to Peter's heart. I'm just going to walk through the demo real quick, and then we'll talk about it some. I'm making a table called company drones, right? And now I'm making a table called support drones, which inherits from company drones. So now if we select company drones, we see all of the 3 columns which we initially created, drone name, number of monitors, and sick days. Now when we query support drones, we see all the columns that it inherited from, and then just the 2 extra ones that we added on, support, email, and keeps cool. So now when I add Rob Sullivan to company drones, we see that record in the company drones, but no records in support drones. And when we insert Peter into the support drones, we see both of us in the company drones and only Peter in support drones. Thoughts on this?
And what more is there to say than modeling your objects, just OOP design in general? Everybody knows that abstraction to your objects, separation of your data, keeping things that should only be in one place, it just marries up so nicely to all of that. Unfortunately, inherited tables like this are not yet fully supported in .NET, or at least in the data providers that are available for free for .NET. I believe there's a commercial one. I really do wish, however, that they'd just hurry up and get this into NPGSQL, because if you were able to take your object model and your relations in that object model and you abstract it out like this, and that would be just a win-win situation for everybody. Forget foreign keys. Foreign keys are old school. Are old hat when you compare it to the ability to be able to do this.
Well, it's a fun little exercise. Let's also try and drop the company drones table and see if we're going to lose all of our support drone information. It's not going to let us drop. So when we're mentioning foreign keys, there's a very tight relationship between these 2 tables, the table that it inherits from, almost like a foreign key. Does that make sense to everyone watching? When we made support drone be inherit from company drone, we can't just up and kill company drones now without extra work. And you might like what Peter's talking about on the database side, on the app dev side, but on the DBA side, this is the foundation for table partitioning in Postgres. This doesn't require an expensive enterprise licensing just to get some physical partitioning. I can do it right here for free in a way that's pretty straightforward, which I absolutely love.
Partitioning is just absolutely ace when it comes to handling massive amounts of data. I recently worked on a project where there was just millions and millions of rows in a table, and we designed this table because we didn't expect it to hold the volume of data that it was going to be held. And it wasn't until we put it into production that I actually looked at it and thought, you know what? This thing should absolutely have been partitioned. And the way we'd structured the data, the way we'd structured the keys, the columns, and the data in the columns, it absolutely lent itself to a perfect partitioning scheme. Unfortunately, when we started on MySQL. And we kept on running on MySQL. We did have a vision to move across to Postgres. We never made it. But I absolutely wish that we'd gone on to Postgres right from the word get-go, because as Rob's about to show you, the partitioning is so easy that this would have just solved all the problems that we had with the massive amounts of data that we were trying to handle.
Yeah, so we could take this, we could do support drones by year. We can make more tables by company. Like, there's just any number of ways to slice it and have it all available in company drones. And if we look at the execution plan on company drones, we get it. See how in true table partitioning format, it's hitting both tables and grabbing it together. It's just really neat stuff. It's just a great tool to have in your tool belt. Speaking of great tools in your tool belt, who has wished that SQL Server would support regular expressions?
Oh, definitely. I would absolutely love to be able to put regular expressions into a like clause.
Out of the box with Postgres, you get regular expression support. So we're inserting raw burrito, chili burrito, and taco wrap. When we want to look for just tacos, it pulls taco wrap. If we want to regular expression match on just burr, it gets both burritos.
And is this full Perl regular expressions as well? Does it understand the full incarnation of the Perl syntax? It's. I guess what I'm asking is, it's not a bastardized version of a regex like it is in some query engines, right?
Right, but you can tell by how the syntax gets a little weird. Every time I have to do this, I go straight to the regular expressions help page and look up the syntax, the options I have, but it's pretty legit. It's just hard to memorize.
So it's the real deal then, the real I am, for sure.
For everything I've done, completely.
And of course, does this work across every index type as well? Because, well, Postgres has a lot of different index types. Out of the box, we have gin, gist, B-tree, and hash.
Right. So this is obviously going to break a B tree because we're looking for a wildcard mid character. Right. This is non-sargable or sargable by default. So for this field, we'd likely want to have an inverted index or something that deals better with semi-structured type data. But it should be able to grab the index on it. And I believe we can index this regular expression too, if we really wanted to.
That would make a lot of sense.
Yeah, so this might be like a very common one performed, and we could just straight up index this expression if we need to. There's lots of options. Really best to just explore it for yourself because everyone's use case is a little bit different.
Absolutely.
Definitely is there to support you.
So, moving on. Now, here's something that really, really redefined one of the ways that I'm going to start thinking about Postgres from now on. Range types, I really did not know had the power that they have until Rob was showing me the other day.
Okay, we're doing up a new table. It looks pretty normal. Our ID, a truck name, and we have this field called onsite, which we've given a data type of date range. There's also integer range and all types of ranges, but for this specific one, we're using one called date range. Now we're going to insert our data. If we look at our data, we see these various kind of start and end dates for when these trucks are going to be out of place. So, November 15th, 2013 to the 17th. And now when we query, so we should have one that overlaps now. So the No Dogs Allowed truck, which is sitting at this location from 2013 to November 2014. When we query, Postgres is going to understand that this is a range of dates that are valid between these two endpoints. So when we query for it, give me everything that's on site now, boom, right there.
So for those of you who don't actually gel too quickly with what's just happened there, what Postgres is actually doing is it's treating that one variable as an entire block. If you imagine looking in your calendar, you might plan your meetings and your work schedule and your family holidays and things like that on a block-by-block basis. And you might realistically have 2 meetings that collide with each other. Postgres is smart enough to know that that first block constitutes a defined period, not just a start time and an end time. And you wouldn't just use like where between this date and that date, as you would in SQL Server to do range checks on it. It actually understands that that is a block of time. And not just with date ranges either. It can do this on IP addresses, it can do this for integer ranges, floating point numbers. It can even do integer to infinity and negative infinity to integers, believe it or not.
Yeah, it's really cool. Postgres built the building block with the concept of a range, and other companies and other people have taken that concept of range and applied it to a bunch of different data types, which is just extremely neat. And then having these ranges, if someone reports, they got food poisoning on, November 14th, 2013, we can quickly query and see that there's just 2 trucks there that day. Now, this is just querying. What if we can only have 1 truck on site? We can use these range types as constraint filters and constraint functions on top of our table definitions. I don't have the code on top of my head, but we could do some sort of constraint and not allow an overlap for a location. All right, you can look at all of it. There's just a lot of really cool things you can do to make sure that at any given time when we're trying to insert data, or maybe our application code is just real loosey-goosey and doesn't understand these checks, at the database level we can be very strict about not allowing range overlap, or allowing range overlap, or allowing range overlap of 2 or 3 times. I know, Peter, you're a huge fan of functional constraints and stuff inside the database, is that correct?
Absolutely, absolutely. I mean, being able to just throw data at the database and for the database to decide what it should or shouldn't be able to do with it is just win-win for me. If I had a planning application or a scheduler application, for example, okay, shall we see if we can allocate time for this meeting? Well, which would you prefer to do? Would you prefer the database to tell you, just for some simple maths, that you can or can't save that date? Or would you actually prefer to have to sit and write lots and lots of code to test different relationships at your app level? Then bearing in mind that if you're going to sit and write code to test dates and date ranges and whether a meeting overlaps with another meeting or not at your application level, you have to write the unit tests, you have to write the business logic, you have to bring those decisions backwards and forwards to and from all the different tiers in your application. Isn't it just easier that you can turn around and say, hey, Postgres, put this data in your database, and Postgres will just go, no. Simple as that.
Yeah, then your logic just wrapped around parsing that fail code.
So Kevin asks another question while we're on the subject of ranges, and it's applicable. Why in the on-site date range open tag and close scope? I think what he's on about, I'm not sure again if I'm right or not, but I think what he's referring to here is the open square parenthesis and the closed curve parenthesis.
Correct.
Would you like to give us some more details on that, Rob? Because that's going to throw a lot of people, I think.
Yeah, and this is one of the interesting things. Like when you get all this add-on functionality and all these different things you can do, you have to have ways for the engine to be able to parse it and understand your intent of what you mean by this. So it understands that when we have a date range, I need to lock it in some sort of way that understands the start point and end point. Well, array is a natural fit for this. So it's just kind of using it like an array block. And there's, again, you want to look up for some stuff. The documentation on this stuff is really well. and it'll explain to you, why it needs these tokens to parse and create value in a certain way. Again, look at how we query it at, greater alligator. That doesn't really make sense to us, and it's really crunchy that we have to try and memorize. But we need a way to let the engine know that our intent, that we mean to, I want things, on this date.
I also believe that when you're setting up a range value, that there is a difference between the square parentheses themselves and the curve parentheses around each side of the range value itself. One means inclusive, the other one means not inclusive.
Yeah, great point. And again, this is why when I start using some of these exotics, I just go straight to the documentation to refresh. This is a lot for any one person to try and remember or memorize. So again, I always just say refer to the docs on this. The other thing that, any framework doesn't help you out a lot because it doesn't understand these data types. But in other programming languages which have really flexible and really intelligent ORMs, you just create another hook in your ORM, and your ORM does all this translation for you, which is really nice.
Absolutely. I believe that nhibernate on Windows under .NET does cover PostgresSQL, but I'll put my hands up here. I'm not an nhibernate user, so I really
not many are.
I really couldn't tell you what its level of support for this kind of stuff is. I tend to use ADO.NET, just raw ADO.NET, and I do all my own SQL and model calls and that from within my own code. Now, many people might actually call me mad for doing that, but it's purely and simply because most of the ORMs that are out there for .NET that I use that work against NPG SQL actually don't have an absolute clue what they're dealing with behind the scenes. They treat it just as another dumb data store, and vast majority of them just don't make any kind of use in any of this.
Cool. Yeah, since we're on the topic of dates, I thought it might be fun to look at a couple fun little date things that you can do inside of Postgres. So we just made up a new table called chrono, timestamp. Again, timestamp in Postgres and other databases is much different than a timestamp in SQL Server, because in other databases it actually stands for a timestamp. So when we insert now, we get our current time. Or maybe we want to add 1 month or subtract 1 month. How do you do this in SQL Server? You'd probably start doing that date add function, which takes in the 3 parameters, whatever. In Postgres, you just say, you add an interval, and then you use human language to specify what the interval is. So it could be 1 month, 1 year, whatever.
Absolutely, and using things like that as well also means that maintenance of the DB itself is actually a lot easier to do from people who might not have worked on the project from the beginning. It's quite conceivable. Having people leaving a project and coming into a project is not just a developer thing. It happens in the DBA's world, it happens in the sysadmin's world, it happens in the support staff's world. Right or wrong, Rob?
Oh, definitely.
So things like this, being able to jump in and having the database code self-describe itself, again, how much more easy do you want it to be,
Yeah. Speaking of self-describing, how many times when you have a future date that you don't know, you end up just defaulting, well, I guess we'll put in null, like in SQL Server. We'll just add null because we don't know it yet.
Yeah,
Postgres, you can use this concept of infinity as a valid date type to know that I don't have to use null here. I actually know it's in the future. I just don't know where yet, which is just was awesome for me.
And of course, if you're using infinity, because it's not a null value, you don't have all the horribleness that's associated with having to handle null values. And we all know the arguments and the flame wars surrounding what null actually means. Does it mean devoid of value? Does it mean not a value? Does it mean I don't care? Infinity, you just cannot misinterpret.
Yeah, and you're not wasting time on those null debates.
Exactly. We have another question here from Andre. And he asks, what's the difference between sequence in Postgres and identity in SQL Server? Well, I'll describe identity, and then I'll let Rob describe what a sequence is, yes?
Go for it.
So, everybody's familiar with creating indexes, particularly primary keys on SQL Server, and most of the time you set it as an identity column. So what is an identity column? Well, an identity column is basically just a counter. It is just Microsoft SQL's way of saying, what's the value that's currently in there? Oh, I don't know, it's 4. We'll add 1 on to that, and we'll make the next one 5. Has 5 been used? No, it hasn't. We'll use that. Has 5 been used? Yes, it has. Okay. We'll add 1 onto that, and we'll keep going until we find a value that we can use. Identities can also have an optional increment, so they don't have to jump at 1. They can be jump of 2, 3, 4, 5, anything that you care for. However, they can only be integers generally. An identity column, for example, can't be a floating point number, so you can't go up in increments of a number. Everything has to be whole, and it has to be round. Rob, as I'm sure is going to show you, will show you that sequences are far more flexible than that.
Right. A lot of times you see benchmarks with Oracle and Postgres and SQL Server and how slow SQL Server will be on certain inserts to these other ones. It's because SQL Server uses that identity concept where these other databases use this concept of a sequence. So as we can see here on the schema layout, this sequence isn't tightly bound to the table. It's its own independent object that we can configure in different ways, and then in our table itself, when we define it, it's trying to give us some nice wording, but basically this serial is saying use this burrito truck's sequence. So it's going to look and feel and perform like an identity, but because it's an object outside of, I don't know how to explain this without going into the internals. The identity is very tightly bound to the table, and drama comes with that. Now, sequences, since they're outside the table, they can perform very quick because you're just incrementing this object, right? But as I'm sure you can guess, you can start setting yourself to shoot yourself. You can start setting yourself up to shoot yourself in the foot if you don't maintain this, or if we start trying to go outside of the sequence world. So let's go back to our burrito trucks real quick.
Absolutely, because with an identity column in SQL Server, there are various rules that it will obey. When it reaches the end, for example, it will loop back around to the beginning automatically and things like that. If I'm correct, sequences are not quite as intelligent as that. You have to manage them a lot.
Right. So, yeah, you're trading speed for that. So here we're going to insert into a burrito trucks where we're hard coding the ID 10, and it goes in just fine. Now in SQL Server world, if we're using an identity, it's going to freak out, right? You don't have the identity insert turned on. It gets very strict about this. In Postgres, we can just do this all day long, and then when we start inserting natural rows, you're going to see where the bottom drops out here in a second. I should have picked a lower number. Hold on. Boom. See? And here's that. And of course, SQL Server now, I think SQL Server 2014 or maybe 2012, they started trying to support sequences too. I don't know if there's a marketing checkbox, but they perform kind of the same way.
Yes, I believe they do. And again, correct me if I'm wrong here, but one of the other advantages of a sequence, because it's a separately defined object in Postgres, and like any object in Postgres, it can actually be manipulated from within a function or a user-defined procedure or right, some other piece of scripted code. So you can see there that Rob's sequence has an increment of 1. He could quite easily have a piece of script on a trigger that looks at the value he's trying to insert and goes, oh, hang on, there's a 10 already in there. We better check there's no other default values, and actually skip over all those values in a piece of script, in a trigger, and alter itself to increase its step size so that it can fix its own problem before it even causes you a problem.
Yeah. So I mean, pros and cons to both. A lot of databases like sequences just for speed because it's just a simple incrementer. Some of them like SQL Server like having it tightly bound. I'm pretty indifferent. In some ways I favor sequences just because I've been really used to it lately. All of them have gotchas. You just have to know what you're getting into.
Absolutely. Right, so we'll let you move on, otherwise I'm not going to have time to do the EF stuff.
Right. So this next one is this concept of enums, which is really cool. If you're a coder, you're very used to enums. They're very helpful. In databases, this is usually a feature you kind of have to mock and pretend in other databases. Enums are a full-fledged data type in SQL Server, and we're going to see its use here. When we declare a table features, we're not just using text or creating an ID that points to another table. We're using our straight reptile type that we created as an enum. Let's build the table. Then if we try and insert a reptile type that isn't in our enum, webrat, it's going to freak out. We're going to error code. But if we insert an animal type that does exist, it likes it. So we have all the flexibility of coding with enums and all the relational integrity of data type enforcement, which is really cool. You can also use this to replace, again, another way to get around excess one-to-many joins. One-to-many joins. No, I have a broken demo here. Let's move on. But as you can see with enums, we're not having to go to another table to look up alligator or a reptile type. It's just right here. It's tightly bound. It's relationally consistent with what we know to be our reptile types, which is really cool. Next, if there's no questions, we'll just go straight on to Hstore and trying to get key value stores and document stores inside of our database, which is really neat. Here's Hstore. Again, we use a specialized data type called Hstore. We just created the extension for it. Now we're going to insert. And again, it looks like we're just inserting strings, right? We have a single quote, some weird syntax, all this stuff. But when we query it, it still looks like we inserted just a random string. And now it kind of looks like we're in maybe a MongoDB type world, right? Where we have an ID and some fields and then a bunch of metadata. So people like the document stores for rapid prototyping. We're not having to get a real strict schema on our prices, on our toppings. We're not building out topping tables. We're just throwing it all in. But the value of Hstore is that since we defined it as Hstore here, the engine knows, and we've conformed to the syntax, we can use special operators to pull the value out. So now we're looking for all the rows where toppings exist. Maybe we want all the toppings that are like cheese. And we can very quickly and very easily derive value out of our data. Let's see, rows that have a burrito name, rows that have a burrito name of lettuce. It's just showing some of the different operators you can do. It's really cool. And on top of that, we mentioned different indexes earlier. Here we're using a generalized inverted index called gen, and we're indexing it. How about I drop it? So since again, this is all a weird string, and we can't necessarily do a B-tree index on this, right? Because it's not going to understand some of the stuff. So we use these special inverted indexes on the details, which is the Hstore type, and now we can very, very quickly query this stuff. And of course, what's an enterprise edition feature of SQL Server? Being able to index concurrently in an online fashion instead of doing a whole table lock. Again, you get index concurrent, which is an online index rebuild out of the box of Postgres. This is kind of a lot to take in. So is there any questions?
I can't see any.
But this is one thing where app devs love Postgres, is being able to go into semi-structured mode, just store it, And me as a DBA, when our prototype comes into fruition, or we fleshed out this idea, I can easily say, okay, well, I see our structure here. Now I can very easily make a relational model out of this, and we haven't lost a lot of time trying to spin up maybe a MongoDB server or trying to define our schema up front, right? We're letting the devs do what they do best, and now as a DBA, I can start doing what I do best and start enforcing some relational consistency when I know what I'm getting into. We're making the best decisions at the best place instead of a point of ignorance.
Absolutely. So instead of doing a massively architectural model up front and sitting trying to work out every problem that you're likely to come across, which, let's face facts, we know is practically impossible with most projects, you actually get a lot of flexibility, in fact, to play. And, well, as you rightly say, that's what us devs do best. We play with technology.
Yeah, I just love this compromise on both sides of being able to build really good applications quickly and intelligently by dropping into something like Hstore. And let's flesh out the big stuff and then make really solid decisions based on what we've learned. Now we have a question. There we go.
Dan, wondering how well it integrates with the F6.2. Stay tuned for that, Dan, because you're going to find out all the gory details very, very shortly, my friend.
All right. Moving on, I've already made fun of XML. Why am I making fun of XML? It's because I use JSON. I use JSON a lot. I use JSON for everything, and it's nice to have a database that understands and respects JSON. So here we're creating a table with a JSON data type. Here, from inside Postgres, we're calling out to an API. And if you guys don't think this exists, let's go show. Here's our payload, right? Same URL, JSON, valid JSON. We'll go import it from an external API into our database. Now we have the data, and more importantly, it's not just dumb JSON in there. We can grab the actual payload and get value out of it.
And for those who were looking at this and again watching and going, what the hell did he just do? Rob, would you be so kind to highlight that copy line for us, please?
Yes.
You will see that he's actually calling an executable on his local file system directly from within a database SQL statement to go and open an external HTTP endpoint, which then pulls the data directly straight into the database without any middleware, without any fugly hacks, and it just works.
Pretty awesome. I will absolutely love this.
Yeah, at this point when I was going through this the other day, my head was about ready to cave inwards. I'm sure many people out in our audience there have looked at this kind of thing in Postgres before and thought, I would love to be able to pull straight from this web service and that web service and such an application straight into my database. And you're then faced with the, well, I need to write a CLR extension for it, I need to make that CLR extension public, then I need to write the support SQL and the support procedures, and then I need to marry it all together, and I need to make sure I've got the right column types, and you've just done it in one statement.
Yep. And I use this one because it's very simple. It doesn't have to be an external a JSON API. This from program lets you have infinite combinations provided with all the different data types that you have. You can do a lot of really cool stuff with this. This just makes for a really fun demo of just grabbing an external API and very simply, in 100 milliseconds, populating my database with data without having to build a bunch of tooling and excess code and excess projects floating around.
Well, moving on anyway.
Yep. This looks really cool.
Just before you tell people what this is, I'm going to give our people listening here a chance to see if they can guess what they're actually looking at there. Any takers? Anybody want to put anything in the Q&A to take a guess at this?
I'll give you a hint. Node.js.
Nope. It's a pity because I've got some week-long plural site passes here that I can give out. Yeah. John Segara, V8 JavaScript engine, definitely my friend.
So
go ahead, Rob.
hopping in, this is one of the reasons I don't necessarily run Postgres on Windows. There's a lot of reasons for this. When I try and add, Postgres, it's very easy to get. There's an extension that puts the entire V8 engine, basically the thing that powers Node.js, inside of your database. You do it with this PLV8 extension. Again, I don't use Windows full time anymore, so I didn't spend a lot of time getting this to work. We're going to hop over to a Windows or a Linux box where it already exists. Now I'm creating a stored procedure. Now I'm calling it that. So let's walk through this stored procedure really quickly. It's creating a Fibonacci sequence in JavaScript, and since it's in JavaScript and we've set the language as using VL8, it's going to parse it and run it with essentially the Node.js engine as our results. And it's quick. Now, maybe JavaScript isn't your thing. Maybe you like CoffeeScript. We can do the exact same thing in CoffeeScript. We can do it in Perl and Ruby and a variety of other languages.
Yeah, I believe PHP and Java are also available. And I've actually heard, and I've not seen it, I've not tried it, but I have heard that it is also possible to embed C# and other .NET code into an embedded language in Postgres as well.
Right. So I haven't done a lot of this in the real world, but this is definitely a space that's really growing. And I wanted to show you this Bedrock, this PLV8 Bedrock project, of how you can start using npm modules and different other aspects of like Node.js inside of your database engine. So you can use Browserify to bundle your code and minify it. There's a whole migration section in here. It's just really, really neat to see people latch onto the extensibility of Postgres and really start taking advantage of V8 and relational engines.
So Eric asks, can you import the content of the script from the file system instead of from inline? He's thinking large, complex script.
Here for the copy?
I guess that's what you're asking.
And I would say yes. I'd say everything local is going to be way easier than external dependencies like this public API.
Great stuff.
Yeah, copy is incredibly powerful, and this from program just gives you a ton of options. And so, if I'm on Linux, I would just do the same thing minus specifying the program here. I love how portable this is. But yeah, everything from program. I don't know how many times I can keep saying the same thing. This is immensely powerful and really cool, and has opened my mind to a lot of different ways to do things. I'm just a huge fan of just the flexibility and power behind this combination of syntax.
Well, absolutely. I mean, copy from a program and then imagine feeding that into a V8 JavaScript procedure directly in your database core. Well, hell, come on, Rob. You guys will be making us app devs redundant before.
That's the plan. That's my global domination plan. Get rid of all the app devs.
Damn you data magistrates.
So moving on, Peter's a big, huge GIS fan. GIS is a bit harder for me. I don't quite grasp it. So for me, a lot of times I just have to do simple distances. Like I want to know how close these burrito places are from my house. So I don't need a whole GIS setup. I just want to add a simple like earth distance extension, create my table. How about delete? Now create my table, insert my burrito locations and burrito venues, and now just get the closest ones. So I can get it in miles. I can get it in meters. There we go, ordering by distance. So now I know that Captain Fish Station is the closest place I can get my favorite burrito. It's just really cool. And do you have anything to add here with SD-Distance?
Not unless you've got a full PostGIS installed to test that.
No.
But what Rob's just showed you there, with a simple earth distance, you have things like st_distance, st_ comparisons, and many other geographic functions that will just automatically take advantage of this lat long measurement. But as Rob rightly points out, you don't need to use ST distance. You have the ultimate flexibility of being able to pick and choose just the bits and pieces that you need.
Right. So, at work or at home, like this burritos distances, this might get more popular, it might not, but we haven't invested a lot of time building things that we don't know if they have value or not. So this is simple. Add an extension. We already have a lat long, just a simple distance query, and then we'll start taking it from there.
And of course, going back to the whole prototype thing, like before when Rob was describing Hstore, for example, well, you can see straight away that we could prototype things using these simple earth distances and simple setup with the data types that Postgres understands, and you could then move on to migrating that very easily to fully geographically aware things such as ST distance comparing two separate geometries on different tables, things like that.
Yeah, right tool for the right job.
Absolutely.
All right, last demo. As a DBA, sometimes in the SQL Server world, I've had to deal with asynchronous triggers by way of service broker. If anyone's familiar with that situation, I share your pain. The whole time I've messed with service broker, I really wanted, I just wish there's a simple, clean way to implement this and let my asynchronous trigger run. And when I came to Postgres world, I saw this listen notify command and was blown away at how simple it is. So if I want to create a listening, if I want to create a queue, a publisher subscriber queue, I just say listen and I give a channel name. And when I want to talk to that channel name, I say notify the channel, and then I give it a payload. So this could be, this is app devs everywhere. This could easily be, primary key, burrito truck table or whatever. So I'm just passing a payload that something will listen for and have a set of rules to act on it. It's just really neat. So we listen, and then we just commit. It says, we can check that it went into the queue, and we get a PID.
And of course, these notifies can be fired from triggers and stored procedures and functions and just about anywhere, including that V8 sample that Rob showed us previously.
Correct. You fire it from your application. Again, it's just a very simple syntax hook that opens up a ton of power by having a built-in pub sub queue inside your relational engine instead of trying to hack stuff together.
Absolutely. And Redis, Postgres, you can see there in Rob's comments that this listen and notify thing could be built directly onto a Redis queue or a RabbitMQ queue or just about anything like that, and it will automatically look and listen, and if it sees anything, it'll react to it. If it sees anything in the database, it can send it out across Redis or anything else you really want to. Yeah,
so I have both here because you can get a really cool two-way publisher-subscriber synchronization going here. Since Redis has a built-in pub sub, and your app can use Redis to query Postgres. Likewise, Postgres has a read wrapper for Redis, so inside Postgres you could be querying the pub sub on Redis. See, a lot of people, myself included, I use Redis as an intermediary cache. It takes a lot of load off my database and stuff, and it's just insanely quick. And being able to use that intermediary memory database to be able to push changes, whether it be cache or persistent changes, and using the pub sub functionality on both is just incredibly fast, and it will really start to change the way you architecture your applications and your data layer.
Absolutely. Right, well, we're going to run out of time for me to do the EF stuff, so let's just quickly answer these two questions that we have, and then we'll jump across into Visual Studio. How does that sound, Rob?
Go for it.
Yeah. So Eric mentioned before he was asking about running a script straight from the file system. Well, he's actually clarified his question. Oh. So basically what he was asking was something along the lines of, can he set up, say, for example, a JavaScript on his local file system that then gets called into the V8 engine and can do create or replace function, create or replace table, etc., in the database. So rather than putting the procedure into the database, the JS code into the database, could he have that read from the file system and executed when the procedure is called? Does that make sense?
Yeah, I don't know the answer, and I would probably lean against doing that. Just because I personally
would as well.
I'm just a little fearful of adding a lot of dependencies that don't necessarily make sense, and having to hit your file system to run your code instead of running it inside the engine, especially when you can use things like Bedrock to minimize your code. That's just me. I'm a DB. I like to play it safe, keep it all in the engine where possible. I don't, and minimize things on the file system that can be executed by the engine.
Now, Andre has a very, very interesting question, and this could actually take an entire 90-minute segment in its own right. Which mobile database is the most compatible with Postgres? SQLite? Are there others? Or are there a compact version of Postgres SQL, much like SQL Server has SQL Compact? Well, I'll give my take on that. SQLite has an extension called Spatialite, and Spatialite basically gives SQLite the fully OGR simple features architecture that Postgres has in Postgres. From an anti-SQL point of view, SQLite also is very, very broadly anti-SQL 96 compatible, the same as Postgres. However, I don't believe SQLite can do a lot of the extra stuff, such as the ranges and specialist data types that Postgres can. However, Rob, you might have other ideas on that, I believe.
Right. So SQLite essentially runs on every mobile platform, and I don't think the SQL Server compact engine runs on very much.
No, it doesn't. In fact, it only runs currently on Windows-based systems. It doesn't even run on Mono properly.
Yeah, and since you're likely, from a business standpoint, not targeting Windows 7 because of lack of market share, you're probably best off with SQLite because it's ANSI standard, and Postgres falls more in line with that common ANSI standard than, say, Microsoft SQL Server. But again, SQLite is just an awesome all-around tiny utility database. I'm a huge fan of it, so I'm just more inclined to go SQLite anyways. It's really cool for what it does.
Now, one thing I will say in regards to this question, however, one good way that you can use SQLite and Postgres is actually the way that I do in one of the projects that I'm involved with. I'm actually involved with a company, and what we do is we do fleet management. That is, we do management of where trucks are and where vehicles are and various assets belonging to companies and things like are they obeying the speed limit, that kind of thing. And we've been working on a project where we are actually putting some of the intelligence from the database directly into the cab of the vehicle. And what we've actually done is we've built this software that bridges the gap between Postgres and SQLite. The mobile devices that are fitted into the cabs of the vehicles have an SQLite instance deployed to them that is fully geospatial aware. The main chunk of the data and the actual data that's put together for the vehicles to obey is done in the back office in a Postgres database. And the two of them actually have calls to and from each database through this bridge software that we've written to marshal the process, which allows Postgres to translate its GIS information into SQLite in a format that SQLite's happy with. And because the both of them are very broadly ANSI-SQL standard, there's not an awful lot of difference between the different types of data. So it actually works really, really well to combine them both, where you have the Postgres in the back office, but you have SQLite out in front on the mobile platform, on the tablets, on the laptops, on the computers themselves. if that's the kind of thing you're looking at doing. What about your take on that, Rob?
I don't know, so we do a lot of mobile at work in various platforms, and I just say SQLite. I didn't know about the GIS extensions. That's really cool.
Yeah, it's called Spatialite. I think it's up to version 4 now, something like that. But if you go on to codeplex.com and you download many of the mapping and GIS kits off from there, such as SharpMap or Sharp GIS, things like that, you'll find deep down in the core of them, all of them have SQLite and Spatialite already baked in. Complete with fully managed .NET assemblies as well. It's actually possible to write an entire GIS application that will interface directly to Postgres and PostGIS with nothing more than a couple of NuGets. However, on that point, we've got 4 minutes left. So hopefully you guys won't mind if we run over a little bit, because this did take a little bit longer than we had to. I'm not going to be able to take you through the creation of an application right from beginning to end, which is what I was planning on doing. So what I'm going to do is I'm going to switch to my desktop here, and hopefully you can see that okay. Am I clear and present there, Rob?
Hold on, let me navigate a live meeting. There we go. Visual Studio Ultimate 2013.
Now, for some reason, I seem to have lost one of my monitors. That's not particularly good, so let me just see if I can quickly switch back. Yeah, that was frightening. I don't quite know why that happened, so let me just reorganize things on the desktop so that I can see the applications that I need. We'll bring this over to here, and we'll bring all these various Postgres windows over here. Because there's actually quite a lot of things that you need to do to make Entity Framework play nicely with Postgres. Unfortunately, it is a bit of a pain in the backside. Also worth mentioning, all of the code that I'm about to show you and all of the code that Rob's already showed you is all available on a GitHub repository that we've set up for this demo. And you'll be able to download it after we've finished. So I'm going to just try switching back to my desktop again now. And hopefully you'll be able to see things now. Rob, please be sure to tell me if something doesn't work.
It's still dark screen for me. There we go. It's coming alive.
So everybody will recognize what they're looking at here. We have a simple Windows Forms application loaded into Visual Studio 2013. Now, I'm using 2013 Ultimate here, but I'm certainly not going to use any of the Ultimate features. So, how do we add and use Postgres in a .NET application using Entity Framework? Well, it's actually not as difficult as you might think. First and foremost, though, let's just have a quick run through the code before we go any further. As Rob's already mentioned, Postgres is notorious for being case sensitive, and that's because of its roots in Linux. Now, the problem with that is many devs that I know in the .NET arena like to use camel case and various other forms of notation when they're creating their POCO objects. So you'll see, in my case here, a very, very obvious case of capital letter on the front of each of my property names. Now, how do we make that play nicely with Postgres? Well, we simply use the component model.data annotations model. You can see straight away here that I've told Entity Framework to use a lowercase version of my table. It's also very, very, very important that you use this schema call. The reason it's very important, as many of you may know, that Entity Framework by default looks for the DBO schema. And Postgres, by its nature, has a default of a public schema. So if you want your tables to work and appear in the standard default public schema, you must explicitly tell it that here. Now, I'll come back to that in just a minute, because there is a very, very important gotcha that will jump up and bite you on the backside when you start using Entity Framework in .NET. But just moving on with where we are at the moment, you'll see that I've used key to define where my primary key is, and typically that would be defined as a serial or a sequence, as Rob showed you earlier. And again, I'm using column and I'm telling it the lowercase name. Now, at this point, you do not have to set your case names on your columns in Postgres as lowercase. Entity Framework will try and derive column names from your property names, and it will use the casing in the property names. However, what you have to be careful of is that Entity Framework quotes these things properly. If you try to use a cased name and do not surround it with double quotes, Postgres will treat it like a lowercase name, and when it tries to find it, it will fail to find it, and you will get errors such as column not found, table not found, object not found, and all manner of things like that. Entity Framework is notorious for not quoting things, and I've seen some very, very painful solutions to try and get around this. So trust me when I tell you this, save yourself a lot of tears before bedtime, use the data annotations and force your table names and your column names to be lowercase. It's also worth remembering that you have a Fluent API for this in Entity Framework as well. So for those of you who don't like using data annotations, you can use the Fluent database creation framework when you spin up your data context, and you can define your keys and your property names and your column lengths and things then. If you want more information on using the Fluent interface, then I would suggest looking up any of the work that Julie Lerman has done for Entity Framework, because everything there is applicable to what I'm explaining to you here. Other than that, you'll see that this is just a normal POCO object, just like you would do with Code First in SQL Server or any other database architecture that Entity Framework understands. For the data context itself, you just derive from DB context, and as you might generally do with SQL Server, you can override your base there and you can put a PG connection in, and you just use a simple DB set to define your tables. On top of that, you would typically have an API of some kind which basically uses your Entity Framework data object and queries your table, adds to and from the actual table itself using standard calls baked into the Entity Framework. So the code that you're using here is no different to what you would generally be using otherwise. So the question you might be asking yourself at this point then is, how does Entity Framework know to use Postgres as its backend data store? Well, believe it or not, you really only need two NuGet packages. You need your Entity Framework provider and you need npg-SQL. Now, the more astute of you out there may notice that I'm using version 5. The reason I'm using version 5 is preparing this demo prior to doing this presentation tonight, I sat fiddling with the latest release of Entity Framework version 6 and trying to get the Entity Framework and npg-SQL bindings installed and working, And I must have sat for about 3 days trying to make this work. And in the end, I gave up and I went back to something that I knew would work. In short, EF6 is not ready for Postgres yet. Now, it may just be that there have been a lot of changes in the driver model. Any of you who have been following anything that's been available from Microsoft or on MSDN will be aware that EF6 has actually separated the entity framework model out of ADO.NET now, so the unified driver architecture is a lot more separate, and as a result a lot of changes have to be made to existing drivers to make them continue to work properly. I believe it might just be a case that the current version of NPGSQL requires some significant work to bring it up to date. I don't know what the reason is, or what does or doesn't work exactly. I didn't have time to delve into it. All I do know is that if you want to use Entity Framework today, then you need NPGSQL 2.0.12.1 and you need Entity Framework 5.0.0. And if you follow the same sort of template that I have, then everything will just work nicely and sweetly. The only other change you need on top of that is in your app.config. Now you can see here we have a standard connection string just like any other string. There's nothing particularly special about this. You have a server, a port, a database name, a user ID, etc., etc. What you need to add, however, is this little bit of magic here. Once you get this in, and once you get this bit in at the top here, for Entity Framework itself, you can marry the two of them up. You'll also see down here that you need to specify Entity Framework and you need to hook it to your database provider factory. The only bit that is critical to make sure you get absolutely right is this bit here, and that must refer to your actual ADO.NET assembly, in our case NPGSQL. Personally, myself, I prefer using NPGSQL directly and using the ADO.NET style data readers and doing everything in a using clause. But if you follow that pattern, if you make those additions to your app.config, and if you follow the code first structure of doing things the way I have in all of this already, then everything will just work very, very nicely. There are some caveats though. Because you're using Entity Framework version 5, tables and objects will not be created automatically in the database for you. So many of you will be used to putting a POCO together for your objects and things, and then just running your application and having those tables appear in your SQL Server database. That is not going to happen with Entity Framework version 5. What is going to happen, however, is when you try to run things, you are going to get hit with this little exception. And let's just give it a moment, and there we go. So, any prizes for guessing what that's bitching about? Well, as I mentioned earlier, the public schema is Postgres' default, not DBO. So, why did that occur? Particularly since I've already set my POCO up to say use the public schema and not the DBO. Well, let me show you something. If I take my project now and I run it without debugger support by pressing Ctrl F5 instead of just F5, you'll actually see that it doesn't work. Right, so the demo gods have decided to forsake me again. Moving on from that, let me find the query that I needed. That's query at the demo table, that's demo data. That's this one. What you actually need to do to make this work is to create a DBO schema within Postgres in the database that you're planning to target. Now, creating the DBO schema is not enough. Once you create that, you also need to create a couple of tables the Entity Framework is looking for. And as soon as I bring these scripts up, many of you will know straight away exactly why Entity Framework is complaining about that schema and those tables missing. And you'll see that I've got to create an EDM metadata table. And you will see that I have to create a migration history table. Yep, that's right, folks, you guessed it right. When you run your project in debug mode, because Entity Framework is trying to run Entity Framework migrations, and because Entity Framework migrations automatically looks for DBO, that's what causes the exception. And because it can't find the migrations history table and the EDM metadata, it falls over with an exception. Now, for some reason, when you run your program normally using Control F5, then that actually runs without needing to know whether the migration tables are there or not. Basically, if you do a search for the error message that it spits out on Stack Overflow, you will find more than handfuls of people complaining about the same problem. And there's just so many of them that I'm not even going trying to give you the links. If you run the SQL files that are in the GitHub repository that myself and Rob have made available, then you can just run them and they will set the necessary DBO and the tables and things up, and your debugging will then work. The only other thing you need to do after that, as I previously mentioned, because Entity Framework 5 does not create your objects for you, you actually have to create them by hand. Now, I know that kind of defeats the objective code first, but I have been assured that this has been fixed in EF6, but I've not been able to get EF6 working successfully yet, so I have my doubts about that. So for now, if you're sticking with EF5, you need to create your table, which we've just done there. And what I'll actually do is I'll seed this with a little bit of sample data, which you'll see there. And now, when I hit F5, notice I'm running this in debug mode. Fingers crossed that the demo gods are going to love me this time. You should see that, there we go, it actually works. And this now works because we've gone to the pains of making the DBO schema available, and because we've put our tables and everything in there. And you'll see that this sample application allows you to just very simply create a new record. And we'll just put any old stuff in there. We can update, and we can do our normal CRUD operations with very, very little impact at all. And it all just works, it all works nicely. So yes, you have to jump through a few hoops, but once you jump through those few hoops, you'll find that it's just the same as normal Entity Framework code. And you'll see, certainly within the actual application itself there's nothing particularly complicated about it. I've used a very MVVM-like approach to doing this. Any comments on any of that, Rob?
No, it looks really cool. Andre had a question about can we use native framework migrations with Postgres?
Right. Do you just want to ad-lib a little bit while I switch back from my desktop there? Yeah, I have my other monitor back, which means I can see the Q&A panel now, I think.
Do you want me to take over the slides? with the resources, or did you want to show something?
Right, so to ask it, well, I'm not going to switch back to my desktop now because I'll lose my other monitor and I'll lose the Q&A panel if I do that. And plus, we're already 15 minutes over.
Yep. Trying to wrap up.
So we'll just quickly answer Andre's question here. Can we use entity framework migrations with Postgres? Let me answer that in two ways for you. Yes and no. Okay, firstly the yes. Entity migrations should, in theory, work. I've never actually tried them, so I'm not going to give you a definite yes on that. It is something that I am going to play with, and given that PostgreSQL is very ANSI 96 compliant, then that shouldn't be a problem as long as Entity Framework writes good SQL for it. If it tries to use any clever Microsoft isms, then chances are it will not, and it will break horribly. However, as you've just seen from my code demo, Entity Framework Migrations insists on using the DBO. So at the very least, you may need to use the SQL files that I've provided to patch your Postgres database in order for Entity Framework Migrations to do its management. Now, at this point, I'm saying that because I don't know if there is a way to override the migration support to tell it to use a different schema. I suspect there probably is, given that Entity Framework Migrations actually writes C# classes to do the migration up and down in a special folder within your project. So I'm guessing as long as you can change that code, and as long as you can modify things in that code and recompile it, I should imagine, yes, you can use migrations successfully. However, I've seen the horrible side of it, and my experiments so far tell me at the moment, no, and certainly if you're doing as I recommend and sticking with EF5 in the interim, I would definitely say no, because I've not yet got migration support to work anywhere near properly with EF5 in any of it. And that's basically all I've got for that question.
So I have some quick resource slides up. There's the GitHub repo with all the code from both demos as well as the slides. If you're curious about Postgres, there's a website that's planet.postgres.com that has a lot of really good information. If you don't want to peruse the website and just get a weekly email with just some passive ways to learn and different articles going about cool things occurring in the Postgres world, there's the postgresweekly.com. And of course, there's a wiki for Postgres if you just, if you need some, if you're running out of NyQuil and you need something to go to sleep to.
One thing I would say there, postgresweekly.com. I subscribe to that newsletter myself. It's run by a chappie called Peter Cooper, at Peter C on Twitter. Show him some love because he does a huge amount of these newsletters covering Node.js, Postgres, JavaScript, HTML5, many, many more, and he does them all free. Yeah, he makes them available to the community at no charge. Jump on across to the site, register for the newsletters, and give him some kudos on Twitter. He's one of the shining heroes. I've learned a lot of fantastic stuff from that newsletter, and I'm certainly going to be letting him know about this presentation once we've finished recorded it and it's up and running on our YouTube channel. And on that note, I think that's me done.
Cool. I'm done. Thanks everyone for coming. Whether it's Postgres or something else, feel free to try other technologies and play with different things. And learning is cumulative. You don't lose knowledge when you try something else.
Well, thank you very much for attending our discussion, and thank you very much, Peter and Rob. It was an excellent discussion. I really appreciate that you did this, and to the members that are listening, thank you again for attending. And if you have further questions, or if you just feel like, and we would like you to post your questions and comments to our discussion lists on Lidnug. And with that, I think we're done and stop recording.